let's practice making machine learning predictions with our decision trees. So after you have a model that you're satisfied with, go ahead and try model.predict. But what are we going to predict? Well, we want to predict one of the rows of the data, right? Or multiple rows. And it's always good to sort of use the data that you already have, and we can adjust accordingly. So what if we just pick the first row of the data? Well, we would do that using something like x.iloc, first row of the data, all columns. Okay, and if we run that, let's try it as is. We got an error because, what if we try it like this? I just want to try something here. That worked, okay? It has to do with, I think, the type that you end up with. So this ends up being a data frame, not a pandas series. And you can see that you end up with an output of 1. The first person does have a heart disease, according to the model, and we can check it in reality using our Y or even our DF. Let's look at our DF, okay? And so with our DF, we put in basically the same thing. Let's go from 0 all the way up into 1, even though we exclude that. That's a little trick to make it horizontal. And this is the person that we are looking at. So we have this data on them, and it is correctly predicting that they do in fact have a heart disease. Now, I think it's really valuable to sort of put in this data, not the target column, right? That's not a part of it. And we want to see if we can sort of modify the sort of the features to modify the prediction. Okay? And so we put it inside of a list, and then we use commas to separate out the values, doing classic copy and paste. You can just use commas to separate the different values. And then I think the goal here, and this is very valuable clearly, would be what can we change to sort of like put the data through the model so that they don't have a heart disease. And you can see the value here because this could even help in the medical profession in terms of what you advise, right? Like if we change this person's cholesterol, for instance, will that sort of change the prediction? Well, let's first verify that we get the expected prediction using the comma separated list. And we do, never mind the warning, with the 1. Okay, so what can we modify? Well, let's check cholesterol. Now, what's a value that you can modify it to? Well, it's nice to look at the statistics, right? That way you get a sense of like what's in this data set. Now, cholesterol, we can see here, the mean is 246. The minimum is 126. And so we can find out, it's generally speaking, high cholesterol is considered not good. If we lower the cholesterol, like let's say we knock it all the way down to 133, will this change our prediction? Okay, you can see that it does not. Okay, and so now we look for something else to change. Well, some of these you might not know what they mean, right? Like, okay, like what is CP? Well, if you go to the original data set, this is from the UCI Machine Learning Repository. So I simply typed in UCI Machine Learning Repository, heart disease data set. This comes up. Okay, this is our data source. And your data source is where you want to go to get information about what the columns mean. And you can see if you scroll down here, it does tell you what they mean in most cases. I can tell you that CP stands for chest pain. It's not on here. I've seen that elsewhere. But look at this next one. It tells you resting blood pressure. So let's just take a look at these two, the resting blood pressure and perhaps the chest pain. The chest pain is as reported, I believe, not as measured. Okay, so we go back to our data. We know this is now resting blood pressure, and we can look at the different values. Now these are patients, many of them who have heart diseases. So these should not be taken to be like norms necessarily. But we have a resting blood pressure of, 131 is the mean. We've got a minimum of 94, max of 200. Low or high blood pressure is not necessarily good. I'm not sure if one of these contributes more or less to being a heart disease. The average is 131. This person is 145, so it's not an extreme value. You can try some different values, like the 131 doesn't change it. What if it was the minimum of like 94 or the max of 200? You could try those and put them in, and we're not really getting different results. So maybe we leave it toward the middle. Like, let's imagine it's just say average. And the reason why it's sometimes nice to put things to what you know to be good or average is, if you have it at an extreme value, that may keep it at an output of 1. Okay, so we're trying to change this to 0, seeing if we can find criteria to suggest this person doesn't have a heart disease. Now, chest pains is pretty big. I mean, right, like if someone's saying they've got chest pain, excuse me, the probability certainly goes up. And so, like, if they come in and they say, I don't have any chest pain, let's see if this would affect the result. And you can see that it doesn't. So this is a tough one to crack. I don't necessarily have the answers myself. I'm going to kind of pose as a challenge. I'll make one last check. Like, I wonder about this 2.3 here. It's the fourth to last column. What is that? Target is not one of the columns here. These are the predictions. 1, 2, 3, 4. Old peak. So what is old peak? We can see the mean here is this. It's the first one. It's 1.0. So they have above mean. Let's see what we've got here. Old peak, ST depression induced by exercise relative to rest. Sounds very important. Let's just see, okay, if we change it to the mean, which is about a 1. And what do we get here? We still get the same thing. I don't know if you can have a 0, but let's see if we change it to a 0. Still you get a 1. So this is a tough one to crack. And I recommend this process because what's happening, like, as we're going through this, like for me personally, I'm learning about the data. And you want to know about your data. And this would just be so great if you had like a really strong machine learning model and you would have tons of different columns of data and they were things that were changeable. So you could say, oh, look, if the person drinks more water and maybe they exercise more and lower the cholesterol, the probability that the heart disease goes down is considerable, that type of thing. And this is sort of like a process that you can take to move in that direction.